Welcome everybody to our session. I just want to mention this is a live session. The attendees, please chime in with any questions during this session, and I will make sure to tie those questions into our discussions with our panels. The topic of this session is flexible positioning options to allow for versatile manufacturing. My name is Luke. I'm your West District Sales Manager for DESTACO, Camco, and RoboHand Products. Our panels for this discussion is Eric Vandergraaf, President with Gaumont and Sella, and we have Jerry Saunders, our Sales Engineer with Witt and Associates. Thank you guys for joining our live session here. Before we get started, maybe we want to talk about a little bit about defining flexible positioning. And I could start with saying flexible positioning is the term is something not necessarily new, but it's gained a little bit more popularity. The concept behind it isn't something new to the Camco product line. I could say personally that I've been with the company for quite some time, and I've seen these things around for a few decades now. Essentially, the term flexible positioning narrows down to, I would say, the mechanics of it, of the indexing device itself. So for those that are not familiar with indexers, an indexing device has a few things that are essentially the heart of the machine. It has, I always call the 5-finger rule. You've got an input shaft, a follower wheel, housing. A cam essentially is the heart of that index. So the cam itself in a mechanical device, it has machined dwell into it, which defines the amount of stops, along with the follower wheel combination cam followers that are rolling on it. But the cam itself is machined very precisely to stop X amount of times in a fixed positioning indexing. For example, 4 stop, 6 stop, 12 stop, you name it. Flexible automation is defined by the cam now becoming more of a constant lead. So there's not a true dwell position. There's constant motion. And we're using external devices such as a servo or an encoder of some sort that helps us position that cam, essentially the output, into a very accurate position. So the technology itself has been around for quite some time. Utilizing our mechanical background and indexing position with, a collaboration of the cam and the rollers coming together as their preloaded system, helps the servo to position it even more accurately. Eric, can you maybe go a little bit more in detail from the technical side of how that works?
Yeah, sure. And Luke, thank you for having me on. So, traditionally, we would talk about flexible movement as it applies to a servo and servo drive. Servo drive and servo motor are motors that have encoder feedback, so the drive knows where the motor is at any time, and we can control the position of the output shaft of that motor. So here at Camco, we are experts in moving things, and traditionally, our cam-operated machinery did all of that movement simply by cutting the metal in the cam to produce some sort of movement at the output. Now we take that technology and that same math and we apply it to the motion of the servo motor, and we run it through the cam, and we find this servo mechanical combination to be very useful to our customers. So we can control now that output of the cam simply by controlling the servo motor, right? And
correct.
And so we get several benefits from that. One, programmable positioning. You can change the output position of your device. Where the servo motor itself kind of falls flat is it's not as repeatable as the mechanism inside a cam. So we're pairing the highly repeatable cam mechanism with the highly accurate servo motor.
Perfect. No, it's a great way of defining it. Jerry, you want to add anything to that?
Yeah, I guess I would add some things. As Eric mentioned on the technical side, as far as a customer goes, maybe you can put these servo motors not only on indexers but conveyors. There's a lot of flexibility that we add when we go to a servo type system. As we automation today is different from automation 20 years ago. Automation years ago, you used to build a machine to last 20, 30 years. Now people are looking for a machine sometimes because programs only last 3 years. But by adding servos and doing certain data sheets that we can go into a little bit more detail, what might be a 4-stop or 4 position can immediately change to a 5, 6, 7 position, 8 position, whether we want to do multiple different parts, multiple different, parts on one indexer, and we can go into that a little later. Or if you just want the flexibility to say, I don't want to buy a new indexer. I know this thing's only 3 years old, but you can change to multiple different stops later on. So it's really, the technology has really added to another avenue of flexibility long term for the customer.
Correct. No, it's a great point. You could reuse the same system without redesigning the entire machine. You could use that same system, which is a great advantage of going servo. Now, Eric, when we look at some of the product offerings that Camco provides, can you maybe give us a little bit? I know we talked about this topic yesterday on one of our live sessions, but any advantages going from a rotary to a linear form by utilizing the flexible positioning options, servo and using our Camco drive systems?
Yeah, so it's a good question. So we're experts in both linear and rotary positioning, and the concepts translate from one to the other very smoothly. We're either indexing a rotary output or we're indexing a linear output. Mm-hmm. And their benefits, the benefits are pretty much the same. You get flexible positioning, so you can switch from product A to product B. In linear, we've done applications where on our precision link conveyors, we actually have A tooling and B tooling either on the same link or alternating links. And depending on the product they're running, they can run one set of tooling one day and the other set of tooling the next, or they can do them in every other cycle. That applies to both rotary and linear indexing. Again, we can also use the servo motors to dial in the positions too. So if there are some mechanical variations, we can program that out and get very exquisite positioning too for our customers. And then finally, we can move very quickly and wait for a programmable amount of time while the customer does their work. A lot of people don't want to waste time moving product from station to station. They just want to get the work done and improve their productivity. So servos can help us do that.
Right.
Correct. Go ahead.
Let me add one thing that Eric just said there, and that's the wasted time. Literally within 10 seconds, we can go from one fixture to another fixture if both A and B are tooled on the same precision link. In the old days, pre-servo, you'd have to change out all the fixtures, whether it be on a dial or on a precision link conveyor, and put the new fixtures on. Maybe they don't change one out right, maybe they do. So literally in seconds, you could be running product B, at least the changeover, which is always critical to customers, the amount of changeover time. It's seconds on the Camco side of things.
Good.
Yes.
So go ahead, Eric.
Oh, no, that's exactly what I wanted to say.
We know that applications in general, they vary, throughout sizes and shapes and forms, different forms of automation that happens. There's a lot of things that come into play of choosing the right, I would say, selection. Either it could be floor space. Obviously, sometimes the price obviously comes into play as well. How many different products they want to change, or how many products they want to automate, and processes and so forth. So in the industry, you guys obviously have worked on many applications in the past. Can you guys maybe give us some live examples that you guys maybe have worked with without maybe, obviously exposing the customers' names, but something in as details as you can without exposing too much information?
Yeah, I'll go first on this one, I think. So one thing that the servo and the Constantly Cam have added is, Camco, for years and years, you could get a 5-stop indexer, you could get a 7-stop, 20, 24-stop indexer. Servos give you infinite stops. So there were actually some indexers, depending on whether it might have been the ADRDM or a ring drive that were produced that you couldn't get a certain amount of stops. So what the servos have done is add complete flexibility over our entire product line. So when an engineer is engineering something, they're not necessarily limited because an indexer doesn't exist to do a certain amount of stops. So that's one thing that's really opened up as far as, you know, what a servo can do to compare to what a constant lead cam could do. I mean, that's one thing I think I'd like to add just to start. And I've seen a lot of applications where 5 years ago, 10 years ago, maybe you had to say no or try to switch the stops. That now you can just say, yes, we can do that.
Good.
Well, yeah, and I'd also build a little bit on what Jerry's saying too. You know, people would say, well, if I have this servo motor, why do I even need the Camco indexer or the Camco linear device on here? The servo motor's determining the output. And the answer is Camco's cam-driven mechanism is perfect for marrying with a servo because it is a zero backlash design. And servo motors like very tight, very stiff systems in their control loops. And additionally, the Camco indexer or the Camco conveyor provides that precision mounting base where you can put your tooling and you don't need to engineer something because a servo motor is just too delicate to hold your load on it, right? So we have a wicked combination there. And building on the examples, we combined, and there was one application where we had to move something very fast. The customer wanted less than 200 milliseconds in move time. And we married an indexing cam, a traditional indexing cam that had a dwell in it and stops with a servo motor. And what the servo motor did was spin the cam very fast to get through the motion. So the output moved to the next station very quickly and used the cam rib and the lobe of the cam dwell to stabilize it when it came into station. So you didn't have to wait for the servo motor itself to settle. Servo motors have issues when they're moving very fast. They tend to overshoot and come back. They dither or settling time. By using the cam to control that motion, there was no settling time. And then the servo motor stopped the cam while it was spinning in dwell, much faster than an AC motor could or much faster than any other device could. And that gave the customer time to do their work on the product. So they wanted to work on the product for half a second, but they wanted to move in less than a quarter of a second. We couldn't design a cam to do that. But by marrying the servo with the cam, we were able to give them a wicked amount of output. It was a very effective solution.
Well, let me add one thing to what Eric just said too. It's kind of interesting. When you include an indexer with a servo motor can come with a certain amount of reduction. We can have a reducer that has a certain amount of reduction. And a lot of people don't know this, but our indexer can come with a certain amount of reduction. So when you add those three together, as far as where your RPMs need to be, that's another thing where sometimes by just going to a servo motor, yet that the indexer portion or the indexer reducer portion is very key in sizing the servo along with mass, size, everything else, you know, for you. So I would throw that in a little bit too.
Oh, yes. Yeah, we're experts again in inertia and moving things. And so you can rely on us to help you size the servo motor for the application too.
Right.
You know, Camco, we've been putting servos on our indexers since the 1980s.
Right. And one more thing I would add is we are not limited to any brand of servo. So if we have one, you know, the customers out there listening right now, if Allen Bradley's their preferred, no problem. If Siemens is their preferred, no problem. Mitsubishi's preferred, no problem, et cetera, et cetera, et cetera, et cetera. You know, we can handle any type of motor. There's no limitations on us. You basically, the limitation is we just got to remember to ask the question. And once they tell us what brand they want, we can rock and roll from there.
Perfect. I just want to remind the audience that this is a live session. Please chime in with any questions that you guys may have. Also, in addition, we have a poll question that's going to be coming around. Please participate in that. I appreciate that. Looking at you know, both options, the mechanical versus servo type indexing, are there any maybe cost advantages going from one to the other? Jerry, can you maybe just touch on that a little bit, please?
Well, sure, absolutely. If you're building a machine and it's going to be an 8-stop machine and you're looking at a 30-inch dial or something like that, our 601 RDM is a product line that's been built for many, many, many years. It's a very economical solution, sometimes just as economical when we do an AC motor as what you get a servo motor for, and that doesn't include the indexing or reducer part of it. So if you're building a machine, it's going to be dedicated for 20 years, and from a repeatability standpoint, what Eric had mentioned earlier, and from a cost standpoint, it's really hard to beat the AC technology of a 601 RDM. So again, that's one common question that we, as technical specialists of the Camco products, have to remember to ask. How long are you going to be planning to use for this machine for? Do you see any changes possible? Because if it's going to be a dedicated one-stop for as long as you can see, the AC technology has been out there for years, but it's still a great technology to use.
Yeah, I would agree. The servo is going to give you 3 distinct advantages in that, again, either flexible automation or highly accurate, highly repeatable. And I've done applications where we've had encoder feedback on the output of the cam, and we've fed that back into the servo, and we adjust our position as we come into the station, and we're in single-digit arc-second accuracies, 6 to 3 arc-seconds in some applications. That's quite remarkable at our price point with a servo and an indexer. And then finally, the very high-speed dedicated cam with servo motor combination that can move products in the 200 to 100 millisecond range. That's not even achievable with just a servo motor and a gear reducer. You need that cam to help you do that. So those are the advantages. And yes, the servo drive itself is more costly. Although some of our newer products, the GTD product line, is designed specifically to integrate with servo motors, and that does bring the cost closer to the 601 RDM, as you're saying.
Right. Now, back to what Eric was saying, just one more thing I would add for all the customers out there is just about any of our product lines can be created to be a servo product line. There's some particular product line you like. We've mentioned conveyors. We've mentioned, certain indexers, but pretty much all of our indexers across the board, we can make with Constantine cam, with proper motor adapter and couplings to where we can put any servo if needed in there. So we're not limited on a particular product line.
That's a great point. That's a great point, Jerry. As you mentioned, Camco has a large variety of indexing devices that it could be either both mechanical or servo-driven devices. As Eric mentioned, we do have dedicated product lines, specifically the GTB is a dedicated servo positioning device. So it has a constant lead cam internally. So we do have products that serve both, but we try to also provide products that are specific to the servo market as well. There's another question that came in. We look at the pros and cons of going mechanical versus servo. What is the upkeep and maybe the setup portion of a certain device? Eric, can you maybe touch on that?
Well, sure. So your commissioning time on a servo might be a little longer than a traditional AC drive. It actually depends upon the servo product. But as it integrates into an entire machine design, sometimes the servo is easier to implement because of the way it programs internally in the control scheme of the end user. So many times people might say, well, I want to avoid that. It's too complicated or too hard to implement. But when you actually look at the software and how it fits into the machine architecture, it's not any harder, maybe even a little easier to synchronize parts of the machine if you already have a motor with an encoder on it, because that provides a timing signal for everything else in the machine, as opposed to an AC, open loop AC motor and drive. So there are hidden costs in both, and I would caution a customer, rather than dismissing using a servo motor right off the bat because it's more expensive, the actual integration cost might be lower. So consider that it allows you to digitally time your machine to the motor that's moving it.
Right. And maybe I would add one more thing to that, a little bit from as far as quickness or right things, and maybe this may be the right time, maybe not. We have DC technology, we have AC technology, and we have servo technology. So if you're doing a certain amount of start and stops, the DC technology can only handle a certain amount, and then you got to either flip to the AC technology or the servo technology. There again, when you get into a certain amount of stops, and depending on indexer, the AC technology can handle a certain amount of start and stops, and then you either got to go servo or maybe a clutch brake type technology. So that is one other factor as far as integration, quick startup things that you got to think about during the application.
As we hit on that topic, I think transition into this next question is going to be pretty much seamless. When we're looking at, I guess, industry in general, do we see any specific trends that are maybe hitting or going towards one way versus the other? I know it's customer specific, application specific, but in general speaking, is there a certain trend that we see in the industry?
Oh, certainly. I can answer some of that. So machines are becoming highly networked devices. It's the Internet of Things. And so servos blend perfectly into this because you're getting more information. It's a completely digital system at this point. You're using your PLC or your machine controller to over a network, tell the device what to do. And we're eliminating wires. We're going to more independent, more thinking machines. And as we do that, servos are the platform of choice. So.
Right. Yeah, I totally agree with what Eric said there. I mean, the other thing I might add a little bit, and generally the higher speeds, consumer goods, you're seeing a lot more servo technology than you did, let's say, 20 years ago. It's really catching on for sure in that industry.
Do we see, for example, Jerry, when you're visiting a customer, how does that conversation start with the customer? When he comes to a certain application, he says, I want to do X, Y, Z, how do you steer him into one versus the other? How does that process kind of go about? Can you just briefly talk about that?
Absolutely. So any customer that we call on and we figure out that they have some type of indexing need, okay, whether it be linear or rotary, basically you say, all right, how many fixtures you plan on having in the system, how big a dial plate, if it's a rotary, if it's not a rotary, how much is your fixture going to weigh? You go through a certain figure of parameters. In those parameters, you also act, are we only doing one dedicated part? Do we need the flexibility that we spoke about sooner? So real quick, within the first 2 minutes, we would know, the technical specialist would know, all right, I'm heading in the servo direction, or potentially I'm heading in the AC direction. But that thing is determined very early on. But as far as figuring out for a standard rotary device, what we really need to know is dial plate diameter, dial plate thickness of material, and then we need to know part and fixture weight, how far that part and fixture weight is away from the center of the mast, and then how fast we need to index and how quick we need to stop and your overall throughput. And then the final question is this the dedicated part that you're going to have for a long period of time or not? And if, depending on what those answers of those questions are, it sends us into AC or it sends us into servo right away. And then we start talking specifically as to if you have a motor preference and kind of go take it from there.
Perfect. Eric, you want to add anything to that? I think Jerry did hit it right on, but is there anything you want to add?
Yeah, no, Jerry nailed it. We're certainly consultants to our customers when it comes to that sort of thing. We like to start from the customer's needs and then we can guide them to where they need to go. Rule of thumb might be anything below a half a second of a move time would require something like a servo motor.
Correct.
To do any sort of, effective manufacturing. So we kind of know where we're going when the customer tells us that move time, and then we really nail it with those details.
Yeah, I definitely want to say that I think, as you guys are out in the field working with our customers, you guys are the experts. You guys are our specialists in guiding the customer into the right decision making. We also want to mention that we have inside support as well that will help us with application needs to determine maybe the size of the servo motor that's required or the size of the AC motor that's required, something that'd be driving our indexing devices. So you guys are our specialists and then guide these customers into the right, form of utilizing our indexing into their application needs.
Yeah, Luke, that's a very good point. We have to stress to our customers out there that our recommendations are double checked before they even get to you.
Correct, right.
Your sales application engineer will size it up, but then we run it past engineering at Camco too, and they double check what we come up with just to make sure we're recommending the best solution for you. That's a tradition within our company. We always double check everything. So.
And Eric, you're right on. Just to add part of that, it's kind of a three-way street. So it goes from customer to us, the outside salespeople, outside to inside salespeople. Once the inside and we potentially agree or disagree, once we settle on a solution, not only will we provide you a data sheet back to the customer, but we can provide you 3D models on both metric or English on any particular index that you want us to have or are particularly interested in. That way, our end customers can put it in their machine, take a look at it. If something doesn't fit, well, then we can go on back and try to do this thing again in a different type of solution. So not only do we provide you data sheets early on, right away, early in the application, but we can also provide you both 2D and 3D models. So it's really kind of an engineering solution between both our customers, our inside team, and us, all marrying together to find the perfect solution for the customer.
Yeah. We have even our own proprietary software that can really help us nail it, and we stand by those numbers that we give you. So you'll have that data sheet in your hand saying, this is what we say this machine will do.
Correct.
When we look at, maybe one of the things that maybe some individuals have out in the market, the misconception about speed in a mechanical device. Eric, can you maybe touch a little bit on that and how speed is combined with our cam design and the servo?
Yeah, so I've touched on it earlier, but
a little bit, yep.
Yeah, the great combination here is that we could do very fast indexing and movement in a dedicated cam with a dwell in it, but as customers' demands for quicker moves improve, they need longer time to do their work. So we don't have the time in a 360-degree cam to wait if we've done a very fast move. So that's why we bring in the servo motor, to stretch that dwell time for us. So we do a very fast move on the cam, and then we wait while the customer does their work. The camera inspects something, or they insert a product. So that's the advantage of this electromechanical integration that we do. And we're saving the customer, we're saving you money and time every single cycle of the machine.
Let me add one more point to what Eric just said. Quick moves are important, but sometimes quick moves lead to, on the mechanical side of things, stopping and dwell. And there's certain times when, even though we can index and we can do the number of parts per minute, on a standard cam, we can't stop and dwell in time, and that might lead us also to the servo solution over the mechanical cam solution.
Mm-hmm. Yep.
I understand. Now, looking at, as we talked about a little bit of market trends and how customers are approaching certain applications, I think in the past, and I know we touched on this already, in a dedicated machine, if we're only running one dedicated product for the next 20, 30 years, it makes sense to go to a dedicated indexing drive. I think the trend also we're seeing is that customers are now looking into ways of utilizing that same machine in other products. Traditionally, you would think that you always want to automate the high movers, the high volume runners. with product life in general being, much shorter now. I think customers are looking into utilizing that same machine to other products as well. It could be a product life of 2-3 years, and you're utilizing that same machine over and over. So not all applications obviously fit the servo needs. Not all applications also fit the true indexing needs. But I think as Camco products, we offer a solution that covers all application needs, in general speaking. So in general, I'd like to thank you guys for joining our session here. I'd like to thank the panelists, the experts obviously in the industry. Thank you to the audience once again. Thank you for your participation. I want to make sure, let you guys know that you guys could find any product pages on our website. So please visit our website and find the literature there. This is our last session for the event. I want to thank everybody that was involved. Thank you to our marketing, sales team, operations team, everybody that was involved in making this happen. You have access to this information for the next few weeks, actually, is to the same platform. So with that said, let's automate tomorrow. Today, visit our website, destaco.com, and thank you for joining us.
Thank you, guys.